Today, we are going deep on a really important topic, making your apps unbreakable with Azure Managed Redis. We're going to talk about how to go from just being fast to being truly reliable, covering everything from tiny glitches all the way up to full-on global failover.
Look, we all use Redis because it's blazing fast, right? That low latency is the whole point. But what happens when something breaks? All that speed means absolutely nothing if your app is down. So the real conversation isn't just about performance anymore, it's about resilience. How do you make sure your app just keeps working, no matter what the cloud decides to throw at it?
So to build something that's actually unbreakable, you've got to know what it's made of, right? It's like building a house. You need to know your foundation from your framework before you can make it earthquake-proof. So let's start with the two most basic building blocks in Azure Managed Redis. First up, you have nodes. The easiest way to think about these is as the workhorses, the individual virtual machines that are doing all the heavy lifting for your cache. And the cool part is, you don't have to manage them. Microsoft handles all the patching, the monitoring, the replacing, the whole shebang. But you do need to know they exist because a single node failing is our most basic failure scenario. Now, running on those nodes, you have shards. If the node is the computer, the shard is the actual Redis software doing the work. Each shard is responsible for a piece of your data, which is how Redis can scale and spread out the load. And getting this relationship between the physical node and the software shard is, well, it's everything when we start talking about how failover and replication really work.
Okay, so we've got the basic architecture down. Now let's talk about our first line of defense. We're not jumping into major disasters yet. We're starting with the small stuff, surviving the common, everyday hiccups and local failures that are just a fact of life when you're working in the cloud.
The most frequent problems you're ever going to face are what we call transient faults. You can think of these as tiny, temporary interruptions in service. Maybe a network packet gets dropped, or a server has a momentary CPU spike. They happen constantly, and they usually fix themselves in a second or two. But if your application isn't ready for them, even these little blips can look like a total outage to your users.
And this is where that whole shared responsibility idea really kicks in. See, Azure gives you a resilient platform, but your code has to be smart enough to deal with these little glitches. That means using SDKs that automatically retry a connection. It means you actually have to implement patterns like the retry pattern or a circuit breaker, so one small failure doesn't cascade. And of course, using a cache aside pattern so your app can just go to the main database if Redis is busy for a second. Azure can't write this code for you. That part's on you.
Okay, so your code is tough enough to handle the little blips. Great. But what happens when the problem is bigger? What if it's not just a dropped packet, but an entire server rack, or an entire building that suddenly goes offline? Now we're talking about a much bigger problem, and we're going to need a much bigger solution. This brings us to two really crucial features. First, you've got standard high availability. This protects you from one of your nodes failing by just keeping a live, replicated copy on a second node. Simple enough. But then there's zone redundancy, and this takes a giant leap forward. It takes those two replicated nodes and puts them in physically separate data centers in the same region. So if one entire building has a power failure, your cache just automatically fails over to the copy in the other building.
Now this is the really wild part. When something big happens, like an entire availability zone going down, Azure just handles it. It detects the failure, reroutes all the traffic automatically, and you know what the expected downtime is for your app? Just 10 to 15 seconds. That is an incredibly fast, totally managed recovery from what is a pretty major infrastructure failure.
Now, before you run off and enable this everywhere, there are a few things you got to know. First, you have to have high availability turned on already. This builds on top of it. The good news is it's available on all the service tiers, but it does cost more. And here's the big one. Once you enable zone redundancy on a cache, you can't turn it off. It's a one-way street, so you have to be sure you need it before you commit.
Okay, so we've handled glitches. We've handled node failures. We've even handled an entire data center outage. But what about the absolute worst-case scenario? What happens if an entire Azure region, like all of East US, goes dark? For that kind of catastrophe, we have to go global.
And this is where active geo-replication comes into play. What this feature does is let you link two, or even more, separate cache instances in totally different regions and treat them as a single group. The magic word here is active. This isn't your old-school disaster recovery where one copy is just sitting there waiting. No, all of the instances in the group can handle reads and writes, and all the changes get synchronized between them automatically.
So how does this magic actually work? Well, it's surprisingly straightforward. You just link your caches together. Your application, say in North Europe, writes to its local cache for the best performance. Then in the background, Azure asynchronously replicates that write over to your cache in, say, North America. And get this, if two users in different regions happen to write to the same key at the exact same time, the service automatically resolves the conflict for you using a last writer wins rule. Pretty cool, right?
Okay, now I need you to pay very close attention to this, because this is probably the single most important thing to understand about georeplication. Unlike the automatic failover you get with zone redundancy, here the responsibility for failing over is on you. Azure replicates the data, sure, but if an entire region goes down, it's up to your application to detect that failure and redirect all your traffic to a healthy region.
This means you have homework to do. Your app needs to be able to detect an outage. You need to have a clear plan for when you decide to pull the trigger on a failover. You need the actual code that can switch the connection strings and reroute users. And, just as important, you need a plan to fail back when the original region comes back online. And please, for the love of all that is holy, you have to test this entire process on a regular basis. Don't let a real disaster be your first test.
So we have covered a lot of ground here, from the tiniest network glitches all the way up to massive regional outages. Now let's just pull it all together and talk about how you actually choose the right strategy for your app. Because this stuff isn't one size fits all. It's really a series of choices and trade-offs that you have to make.
This table really sums it up perfectly. Your baseline should be high availability. It protects you from a single node failure, the failover is automatic, and the cost is reasonable. Then you can step up to zone redundancy. This protects you from a whole data center failing. The failover is still automatic, but it costs a bit more. And then at the very top, you have geo-replication. This protects you from an entire region going down, but the failover is manual. It's your app's job, and it has the highest cost.
And hey, one last super important point. Everything we've talked about so far is about uptime and infrastructure failures. None of it will save you if a bug in your code starts corrupting all your data or if someone accidentally flushes the whole cache. For that kind of problem, you still need good old-fashioned backups and a restore.
So if there's one thing you take away from all this, it's that reliability is a partnership. Azure gives you these incredibly powerful building blocks, but it's on you to use them correctly. You should probably start with high availability for just about everything. Then, layer on zone redundancy when you need to survive a data center failure. And for your absolute mission-critical apps, use geo-replication, but be ready to own that failover process. And through it all, always remember, your code has to be built for resilience from the very start.
So there you have it. You've seen the tools that Azure gives you to build seriously resilient applications with managed Redis. The platform is ready. It's ready to handle failures at almost any scale. The only question left is the one on the screen. Is your code ready to do its part?